properties of matrix addition, scalar multiplication, and matrix multiplication. So we'll have uppercase A, B, and C, three matrices A, B, and C that are of the order n by n, so n number of rows and n number of columns. And we'll also have lowercase c and lowercase d as two scalars. So the following properties are true for these. Number one, the commutative property with regards to addition. Now it's simple. It just says that if A plus B is equal to B plus A, so if you add two matrices A plus B, it is equal to, when you add matrices, B plus A. Simple. Now associative property with regards to addition. Now remember, in maths, everything in brackets is solved first and everything else afterwards. So it says here that if you add A plus B first and then you add C into it, it is equal to as if you first add up B and C and then you add A into the resulting matrix. Both of these are equal. Now associative property of scalar multiplication. Now again, brackets first, everything else afterwards. So if you multiply scalars C and D and then you multiply the resulting scalar with the matrix A, it is equal to as if you multiply scalar D into matrix A and then you multiply C into the resulting matrix. Both of these are equal. Now, existence of additive identity. The additive identity is a null matrix. Now let's say first a 2 by 2 null matrix is this 0, 0, 0, 0. This is a 2 by 2 matrix and it is an additive identity for all 2 by 2 matrices. So if you add a matrix into its correspond into a null matrix of the same order, or if you add the null matrix into A, both of these will give you A as the result. So if you multiply any 2 by 2, if you add any 2 by 2 matrix into this 2 by 2 null matrix, or if you add this 2 by 2 null matrix into any 2 by 2 matrix, it will give you that same 2 by 2 matrix as the result. So the existence of a multiplicative identity. An identity matrix is the multiplicative identities. For example, let's just rub this here. Now, see, it says here that the existence of a multiplicative identity, if you have the multiplicative identity multiplied with A, or if you multiply A with the identity matrix, it will give you A as the result. So for example, we have a two by two identity matrix, and if you multiply that with, let's say, this here, it will give you the same matrix. And if you just reverse this, if you put this matrix here multiplied with this, so if you put that here and this here, it will give you the same result, which is this matrix. Now the distributive property with regards to scalar multiplication. Now this here, again, brackets first, it says here that if you add up A and B and then you multiply the scalar C into the resulting matrix, it will be the same as if you multiply C with A first, scalar C with matrix A first, and then you add that into the resulting matrix of scalar C multiplied with matrix B. Both of these sides will be equal. And this is the second distributive property. If you add up the two scalars first and then you multiply the resulting scalar with a, it is equal to as if you multiply scalar c with matrix A and then you add that into d, scalar d multiplied with a. Both of these sides will be equal. Now 7, associative property with regards to multiplication. First, you will always solve the bracket. So matrix B, this says that matrix B into matrix C, the resulting matrix multiplied with A will be equal to as if you multiply matrix A and B and then you multiply the resulting matrix into C. Both of these sides will be equal. Now the left distributive property, it says that matrix B plus C, and if you add up matrix B and C and multiply the resulting matrix with A, it will be equal to as if you multiply matrix A with matrix B and then you add that into the product of matrix A and matrix C. Both of these sides will be equal. And 9, we have the right distributive property. The right distributive property says that if you add up A and B and then you multiply the resulting matrix with C, it will be equal to as if you multiply matrix A and matrix C and then you multiply matrix B and matrix C and then you add them up. Both of these sides will be equal. And the last property here is this one. It says that if you multiply matrix C into the product of matrix A and B, so first the product of matrix A and B and then you multiply scalar C into it, it will be equal to as if you multiply scalar C with matrix A first and then you multiply the resulting matrix with B, or if you multiply matrix C and matrix B and then you multiply the resulting matrix with A. All three of these will be equal.